Welcome to the lecture series on soft computing in computer science. This presentation, what we are going to see is design parameters of backpropagation neural network. In the last presentation, we have seen the architecture as well as the algorithms for, that means net input calculation, output calculation and weight and bias updation, put together backpropagation learning algorithm. That are the topic that we have seen in the last presentation. Here what we are going to see is what are the various design challenges one has to come across while designing the backpropagation neural network. As I said earlier, this backpropagation neural network is a major breakthrough in almost all the latest developments in the field of neural networks. Let me go into the presentation. In this presentation, what we are going to see is how to decide the number of training as well as testing data, how to decide the nature of training, selection of network structure, weights and bias, learning rate and momentum, termination criteria. Under termination criteria, we are going to see what is meant by goal and what is meant by epoch, and how to one can balance between the idea of generalization as well as memorization, and how to study the concept of overfitting, overtraining and validation. So these are the things that we are going to see in this presentation. The first point, number of training as well as testing data. If you could remember in our last presentation that we have seen about, in order to develop a soft computing based model, what we purely depend on, we will purely depend on the data. When you give this data to develop a soft computing model to address a particular real world problem, so what is the first step that you need to do is divide the given data into training and testing. In the training process, you have to focus on developing the model. Once the training is over, we have to focus on how the trained model can be used for some unknown data that might be treated as a tested data, so that the model is ready for deployment or further developments. So in order to make sure about those kind of stuff, this presentation will give you how to decide on the number of training and testing data. So in general, when a data is provided to you, you should able to understand that the training data that you are going to choose should be sufficient and proper. And you should remember that the training data should be selected or randomly. Second point. So what is meant by random here? So if you are provided with, say for example, if you are provided with 100 data, right? So in that 100 data, you need to decide about number of data that is to be chosen for training as well as chosen for testing. Number of data for training and number of data for testing. So the data can be numbered as 1, 2, 3, 4, 5, etc. up to 100. So you should not rely on the first 75 data I can do it for training, and the next that means last 25 data I can go for testing. You should not do like that. You should depend on the proportion. You should decide the proportion, that is I can go for 90:10, I can go for 80:20, I can go for 60:40, I can go for 50:50. Like that I can decide the proportion. That means 90 data I can do, I can take it for training, and 10 data I can take it for testing. That is, we can decide on the count but not on the samples. So how to decide that count of the samples? That has to be done in a random manner. So out of the 100 samples, you need to choose 90 samples randomly for training purpose. The balance will go for testing. In case if you choose 90:10 as the percentage of training and testing. Suppose if you choose 80:20, then 80% of the sample should be randomly selected. Here and there it should be randomly selected. That means one first data, third data, fourth data, seventh data, ninth data, 10th data, 11th data, 13th data, 15th data, 16th data, 18th data. Likewise, you should randomly select. We were not sure about which sample should be included in the training purpose. So that should be completely randomly selected in order to choose the training as well as the testing samples. And next thing what you need to think about is the purpose of scaling or normalization, right? So before training your neural network model, you should focus on a concept called normalization. The idea of this normalization as well as the mathematical expression for normalization that I will discuss in the subsequent presentation. As of now, you should please understand that in order to give the data to the training, you need to decide on the two aspects. One is normalization, another one is something like pre-processing and all. So here I am talking about the normalization and why we need normalization. Why we need normalization? Because if you take a data, say for example in a data I have 10 attributes, I have to have 10 attributes. Let us take that attributes are roll number, right, name, age, right, class, father name, father occupation, father salary. So like that, if you take all these kind of attributes, if you could see that there are certain attributes in this case itself which is very large enough. Say for example, let us take this salary of a father. Sometimes some students whose father working in some corporate company whose salary may be very higher, and sometimes some of the students father who is working in some government sector, maybe salary is a little higher, and sometimes father who is doing a business. So this variable, out of this variable that I have listed, this salary variable is maybe one of the variable in which you can find a variation in the values. If you choose this variable for the kind of study, you may find that there are some variable like this kind of variable which may begin to dominate the lower valued variable. So you have two kinds of variables. One variable is higher value, right? Another value is lower value. So we have two things. One is higher value, another one is lower value. So in order to avoid the suppression of the lower valued variable by the higher valued variable, sometimes this scenario happens. The variable whose value is greater than the variable whose value is smaller will begin to dominate. That means begin to suppress the variable which is having the lower value. That what it means actually, what is meant by suppress, what it means actually, this kind of variable didn't have enough role in performing to the next stage of the process of the ANN model development. So that doesn't have any role. That means it becomes nullified by the variable whose value is. So in order to avoid that, you need to do a task called normalization, whose objective is to bring all the values of a variable in a uniform range, right? So that is called scaling, or it is otherwise called by the name normalization. I will go in depth about this task as well as the mathematical expression used for this task in the subsequent presentation. As of now, you please remember that scaling as well as normalization are a task that might be performed once you decide the nature of number of training data, right? Next. So in general, what you can do is you can go for a percentage called 75%, or you can go for a 60%, 40%, or 50% is to 50% for dividing the training data as well as the testing data. In order to divide the data into training and testing, you should depend on a definite proportion, right? So in that you have variety of proportions like 90:10, 80:20, 60:40, 50:50, like that. So you do not go below the 50:50 because you should have the training data that should be sufficient and proper. So it should be sufficient. You should not go below the testing data. Sometimes you may see that, sir, why how it is if I took 60 data for training and 40 data for testing, it's okay. But in the reverse case, If I took 40 data as the training and 60 data is for testing, means what is the thing happened? There are some more data which are left unidentified, that means which are not utilized in the development of the ANN model, that means during the training period, and it is becoming totally unknown for the testing stage. So that's why you are going to choose a data, and if you are going to design the training data, it should be proper as well as sufficient. In such a way you have to choose the training data. So this is the idea behind how to design the number of training as well as number of training data. And here one thing you need to do is, see, even though you are choosing the different varieties of portions like 70:30 or 75:25 or 80:20, even if you have chosen these kind of the things, you need to have some kind of fold validation, that is cross fold validation. You need to do it in order to get the maximum out of it. So let these kind of stuff we will discuss in the subsequent presentation. Right. Next, nature of training. In what way I have to do the training? So there are two training process. So what are those? One is a pattern mode, another one is batch mode. So in general, what is my training process? Training process is nothing but a sequential presentation of the data. So you have a neural network, what we have discussed yesterday. We have set of input nodes, and we have hidden nodes, and we have output nodes. So those nodes are getting connected, right? This is 3 input, 2 hidden, and 1 output layer model. 1 output layer in that 1 output layer model. So here what is that? The data are given sequentially. Why? Because the training process itself follows the sequential version of the data insertion as well as the data processing. So when you are going to discuss about the nature of training data, all the training process with respect to the data is performed in the sequential manner. That means the training data should be given in a predefined network architecture. So that is the idea here. What is meant by pattern mode? See, here the data are given in a sequential manner, and there are two modes of presenting the data to the model. One is pattern mode, another one is batch mode. So what is the ultimate aim of this particular neural network model? The ultimate aim of this neural network model is to calculate the error between the actual output as well as the target, right? So what we are going to achieve is, you are going to achieve the change in weight value, right? And this change in weight value will be going to use to create a new weight value, and this process is going to be called as the training part, right? So this is what we discussed in the last presentation. But when you talk about the pattern mode, in what way or under what circumstances the errors are calculated, that you should remember. In case of pattern mode, the errors are calculated once you present the data, and the weight updation is carried out for every data. So that you should keep in mind. So the weight updation process, how it has to be carried out. So in case of pattern mode, for every input data, you have to calculate the weight updation process. Whereas coming to the batch mode, here you have to consider, say for example, if I have 100 data, I have to consider this as a 10 batches. So that 10 data in every batch. So for every 10 data, if I calculate the error, then it is going to be called as batch mode. For every data sample, if I calculate the data, then it is going to be called as the pattern mode. So I think now you find a clear distinction between pattern mode and testing mode. If the errors are calculated once a data is presented, and the errors are calculated over an entire epoch, and the weight updation is carried out in one shot. So this is the batch mode. Once all the data. So here I said 100 data is divided into 10 different batches, and for each 10 data that is also a batch mode, or 100 data itself is treated as a batch mode. Entire 100 data is different as one batch. That means you need to calculate the error once the data is presented and the training process is over. Finally you have to calculate the error. Whereas in case of pattern mode, for every data, so here you should remember, here it is one shot, every pattern. So that is the major difference between the batch mode as well as the pattern mode. So normally I think pattern mode is preferable because of time consumption process. In case of some very complexity data, you can also go for pattern mode of data. Selection of network structure. This is very important topic as far as this presentation is concerned, because in the last two slides what you have seen is number of training as well as number of testing data, that it is how to be decided, as well as nature of training, that is pattern mode as well as batch mode. But here only we are going to present how the network structure has been designed. The first point that you need to depend is number of input nodes, and the second point is number of output node. Third point is number of hidden layers, and fourth point is number of neurons in the hidden layer, and the fifth point is activation function in the hidden layer as well as the output layer. So these are all the major points you need to remember before selecting a network structure. Let me come to the first point. What is the first point? It is nothing but number of input nodes. How do you decide at the number of input nodes? You cannot decide, right? Because it highly depends on the problem. Once you are submitted with the problem, or once you are given with the problem, then from the problem statement you can come to know that, so okay, these are all the input variables that are needed in the model development. So according to the input variables, you have the number of input nodes in the input layer. So accordingly you should decide. So that is the first point. Similarly, the case for output node also. When you want to decide the number of output nodes, here also you should focus on the data, and you should understand the data. The data contains one output or two output, or it is multi-category, or it is binary. So accordingly you should decide the number of output nodes. If the output is binary, then one output node is sufficient. If the output is more than one and it is highly non-linear, then you need to put a node for each output category, because the output nodes of the neural network are binary units and it can give either zeros or ones. So according to the 0 and 1 given by the output node, you can decide the number of output nodes for a particular problem, right? Next, coming to the number of hidden layers. So in general, this neural network is called as back propagation neural network, and otherwise it is also called by the name multi-layer perceptron. So here in this name, what is maybe multi? You can have many layers. That means input layer and output layer are fixed. It is counted as one. Whereas in between the input layer and the hidden layer, you can have infinity number of hidden layers. That means you can have n number of hidden layers. If you have as many as possible hidden layer, then you have multiple hidden layer. That is multiple layer. That is multi-layer perceptron. The picture coming to task. And one more important question is how to decide on the number of hidden layers. Again, it depends on the problem. It is a problem specific parameter. It depends on the problem. In case if your problem is in demand of 3 hidden layers, you can choose 3 hidden layers. In case if your problem is very simple enough and you can go for only one hidden layer is sufficient, then you can go for only one hidden layer. Next, to decide the number of hidden layers, it is very important to decide how to decide the number of neurons in the hidden layer. Number of neurons. So I can decide the number of hidden layer like this. I can decide the number of hidden layer between the input and the output. I can decide. But how to decide the number of neurons in the hidden layer? It is also again a computationally burdened task to decide it. But by means of trial and error approach, you can decide the number of neurons in each hidden layer. In general, to begin with, you can introduce only one hidden layer between the input and output layer, and you can start with 2 nodes at least in a hidden layer. So that is a viable solution to begin with. Later on, based on the performance of your neural network and based on the accuracy of the result that is expected by you from the neural network, you can either increase the hidden layer or decrease the hidden layer, increase the hidden neuron or decrease the hidden neuron. Accordingly, you can decide. So the number of hidden layer is again based on the problem, and it normally starts with single hidden layer, and you can keep on increasing and decreasing it. Next important task that I already discussed is number of neurons in the hidden layer. It is based on the problem, and you can start with the 1 and you can go up to maximum, and using trial and error approach, which can give you a satisfactory or good results, you can decide on the number of neurons in the hidden layer. So number of input nodes, number of output nodes, number of hidden layers, number of neurons in the hidden layers are over. And another major important thing is how to decide the activation function, because in the yesterday class, in the last class, what we have seen is, if you assume a node, the node will have two things. One is summation part, another one is activation part, right? So this activation part is the one which plays a major role in order to produce the output of the model. So to produce the output of the model, you need to decide on several mathematical functions which is going to help us to produce the output. Accordingly, if you look at it, transfer functions, training functions, learning functions, and finally performance function. What is the duty of the transfer function? The transfer function calculates the layers output. You are going to calculate the net input, right? Here you can calculate net input. From the net input, if you are going to produce the output, then it is based on the transfer function. And what is a training function? Training function is nothing but how to update the weight values. See, you are going to calculate the change in weight value like del W and del V. So the generic formula is new weight value is equal to old weight value plus this change in weight value. But how to incorporate that? That is by the help of training function that updates the weight and bias according to the Levenberg-Marguerite optimization. So this is the technique that is inbuilt in it, and you need to know about this stuff in order to understand how the weight updation has been carried out. Next, learning function. So what is a learning function? So the last presentation we have visualized this approach, that is gradient descent approach. Gradient descent approach. What it is? You are assumed with a multidimensional graph, and you have a plane of surface, and initially you start with the weight value, for which if you see the error of the process is very higher, and over the period of time it is coming down, and at that time you see that the error is very low. So accordingly you should decide the learning function. And finally the performance function. So performance function is nothing but how to calculate the accuracy of the neural network model. So in general, the famous metric that has been followed for understanding the accuracy of the neural network model is mean square error, that is MSE. That these things you should remember. What are the things? Tan sigmoidal, that might be used as a transfer function to calculate the output from the net input, and another one is train LM, that is a training based on the Levenberg-Marguerite algorithm, and these algorithms are going to be helpful for making the training process. And the learning algorithm, that is a learning DM, that is a GDM, that is gradient descent method. According to that, you need to minimize the error. Accordingly, you need to tune the weight values. And finally, mean square error. And all these tan sec, train LM, train learning, learn GDM, and MSE are all the concepts available in the MATLAB software. And the next presentation will be the fundamentals of MATLAB and the associated algorithm development, that is neural network model development, will be focused in the next presentation. So let me go to the next slide. Weights and bias. So the weights and bias plays a vital role in the model development, yes, particularly model. So it is the duty of one to understand or to find the weight values, and that is called learning. So what is meant by learning in the neural network? The learning in the neural network is nothing but identifying the weight value as well as the bias value. So let me take a simple example. I have a 10 here, and I have a multiplication, I have a dash, and it is equal to 20. So what value I have to fill it here? So definitely you can all give answer as 2. So because 10 into 20 gives the 20, right? Suppose if you are since you are a grown up and your brain has done a lot of mathematical operation, immediately when you look at this problem, you can fill this answer as 2, right? Suppose if you are under the kindergarten level and you are about to study the addition, subtraction, multiplication and all, If I give this problem like a 10 into dash equal to 20, so how you do this? You will use your fingers and you will do 1 10 into 1 so at 10 and 20 minus 10 you have still 10 is there and you have to go for 2, so 10 into 2 is 20, 20 minus 20 0, so my answer is 2. So likewise we are going like a step by step increase, right? So the same manner the neural network model also randomly starts with the weight value. Initially how it starts with that? It starts with the random weight values and you do all the steps of calculating the weighted sum and you do the output calculation, everything. Finally it will compare with the target. If the target value is not matching with the actual output value, so what you have to do? You have to calculate the error and that error is back propagated. So likewise, so that means this is updated. So when I ask this question to a kindergarten student, he will start with 1 and he will start with the 2 again. But when you are if you are grown up and you are very well at mathematics, then it is you can give the answers very straightly. That means you are a completely trained model. But when you take the kindergarten student, that is not a completely trained model. It is in the phases of training. So it will do little updation in the values in order to find the answer. Let me take another example. 10 cross something else, it will give 36. So how I to do? I have to put any value here, any value or any operations here. So how this answer will become? 10 into 3 plus 6. So these three things, right, is equal to 36. I can make this 6 as always constant, always constant. What is that? This may be treated as W and this may be treated as bias, right? So this is called. So I have to do this, but I can go for only 3. If I use 3, then it always become 30. But what I need? I need 36. So in order to compensate that, I need to add some constant value. So this constant value is 6 for this point of case. So what is my input? My input is 10 and what is my output? My output is 36. In between that I need to map. I need to map the value 10 and need to map the value 30. So in order to map the 10 with the value 36, so what I add? I have to add 3 as the weight parameter because there should be multiplied and I should add some bias 6, right? So 10 into 3 will gives a 30 plus 6 if you add, that is 6. And if you look at this thing, the weight is treated as a matrix. Weight is treated as a matrix. Why it is treated as a matrix? W11 what it signifies? It is from the first node to the first hidden node, right? What W2? It is the second node to the first hidden node. What is Wn? It is the nth node to the first node. So like this connection. And what is the W12? W12 is nothing but the first node to the second node, right? What is W2? 2 to second node to second node, right? So what is the Wn2? Like so, like this you need to gather. So now you have to calculate this thing, right? Summation and as well as threshold. So this is why the weight is represented in the form of a matrix. So n processing element with m adaptive elements. So there are n cross m. How many number of input nodes are there and how many number of values that is to be associated. So in this previous presentation, if you see that V11, V21, V31, etc. up to Vm1, like that it goes, right? So that's the thing here. So this is a weight matrix. How these values of this weight matrix are found out? So initialized to a small random values, you keep on updating the weight values in order to produce the faster conversion. That means the faster closing of the network model. So that is the end. So the main important thing one has to remember is weight contains the knowledge about the problem domain. So that's what it is very well. So when you are about to give the knowledge, so what is the knowledge? If I am asking a question 10 cross 2 equal to 20, so if you have a knowledge, then only you can directly give the weight value as 2. So weight always represents the knowledge about the problem domain. So that is what you need to remember. Next, learning rate and momentum. So what you have understood so far? So what is meant by weight and what is meant by bias you understood, and what is meant by weight updation is nothing but a learning process. So what is that? How much weight you have to update every time and how faster you have to update the weight value. How faster you have to update the weight value and how much weight value you have to update in every iteration. So those two things are there. How faster? That is depended by the factor called learning rate, rate at which learning has to be conducted. That means rate at which weight has to be updated, right? For every 0.1 second or every 0.01 second or for every 0.05 second, like that. For every 0.1 second we have to update weight value, or for every 0.5 seconds. So that is the alpha, that is nothing but the learning rate. And the how much weight value, that is eta. How much weight value, whether you have to increase the weight value to the at the rate of 0.03 or 0.005 or 0.07. Initially your randomly assumed value is, say for example, 0.01, so 0.1. So what is the weight value in the next iteration? How to decide the step size from 0.1 to 0. So if you decide the step size is 0.007, in the next iteration it will be decided 0.008 something else, or 0.1, like that. You can go do the calculation, the step size, that is called eta. So when you want to go for this, so alpha is nothing but the learning rate, as well as eta is nothing but the momentum factor. Alpha controls the rate of the weight adjustment and it ranges from 0.01 to 10, and eta controls the ranges from 0 to 1, that is. So what do you need to do? You need to decide on the value of alpha, as well as you need to decide on the value of, so you need to study. If the value of alpha is larger, what is my weight updation process, or what is my learning? If the value of alpha is smaller, what is that? So if it is larger alpha, then it is a rapid learning, that is, the learning is very faster. If it is smaller alpha, then it is the learning is become very slow. So this is the thing. So why you need to introduce this momentum factor? Even though we have alpha, why we are introducing this momentum factor? Because the weight updation should not be carried out as an oscillation. You cannot go for ups and downs and so many negatives and so many things have to be happen during the weight updation. So in order to have the uniform weight updation without any weight oscillation, you are introducing the standard step size for the weight updation process. So that is for the 60. Final one, termination criteria. So what is termination criteria? When you have to stop the ANN process, you need to focus on two things. One is epoch, another one is goal. So what is an epoch? Epoch is nothing but how many number of iterations that you need to execute this ANN model. Yeah, epoch comprises of completely giving the entire pattern. Because if you are doing the pattern mode, the epoch is nothing but the complete giving out the entire data and calculating the error values, that is treated as epoch. So likewise, how many number of times you need to do this process, that defines the epoch. And what is goal? It is nothing but the acceptable error between the actual output y and the target. Acceptable error, that is the goal. So I need to have the minimum as much as possible error value, but that is decided the goal that you need to give it. So these two parameters, it will be very much easier for you when I teach, when I present the MATLAB code for the ANN model development. And how many maximum number of epochs is reached or not, that you can decide based on the goal. So this is critical when you go for understanding the task called generalization. That is, if you keep on training the neural network model over a period of epoch until you expect the desired goal, you should think about the desired balance between the generalization and the memorization. If you do the training process beyond the scope of the neural network model, the neural network model didn't generalize. That means it didn't behave the show the behavior of adaptability or flexibility. It show the behavior of memorizability. Only if the pattern is given, it will give answer. For any unknown pattern, it won't give the answer. So you should always have a balance between generalization as well as memorization. So that is the idea here. So the another motivation factor is you should always achieve the balance between memorization and generalization. And if you are keep on increasing the weight value, you could observe that the weight value keep decreasing until it reaches the saturation point. Over the period, it begins to increase. So you should decide that is the point of saturation, and until that period you need to increase the weight value or increase the focus on the error value, over which you need to stop the process. So this is what you need to focus when you are going for the termination. So the motivation for applying the backpropagation neural network is to achieve a desired balance between the memorization and the generalization. So whenever error begins to increase, the net is starting to memorize. At that point, you have to stop. So this is the idea that you need to keep in mind when you are going for deciding the termination criteria. So what we have seen in this presentation, how to decide the number of training data and the testing data, what is the nature of training, how to decide the weight and bias, and what is the learning rate and momentum rate, and how to decide on the termination criteria. Right. Thank you.